Welcome to the fourth video in this series on special topics in elementary mathematics. A key part of any science is measurement. We keep track of what's being measured by using units. Some familiar units are things like feet, pounds, or gallons. Units are crucial to understanding mathematics as well because they help us interpret the conclusions we reach through logic or computation. In this session, we'll look at how units interact with multiplication and what they tell us about what kinds of objects can be multiplied. Let's start with the area model for multiplication. When multiplication is represented by drawing a rectangle with given side lengths, we are using the principle that the product of two lengths yields an area. This principle is why we usually measure area in units squared. For example, the product of 2 feet and 3 feet is 6 square feet. Similarly, we can imagine multiplying an area by another length to produce a volume by building a box with a rectangular base and a given height. Since the rectangle has an area, which is a product of 2 lengths, the volume may be considered as a product of 3 lengths, so we describe volumes in units cubed. For example, if we build a box 4 feet tall on the rectangle with area 6 square feet, the box will have a volume of 24 cubic feet. Thus we see that two kinds of units can be multiplied to produce a new kind of unit. Being able to produce new units this way can lead to useful abstractions. For example, if a project can be done either by 4 people working 10 hours each, or by 8 people working 5 hours each, then we might say it takes 40 person-hours. This isn't quite a measure of time, because the amount of time the project takes depends on how many people are working. And it's not quite a measure of how many people are needed, because that depends on how much time you're willing to take. You could have just one person if you're willing to allocate 40 hours to the project. It's a new concept, and so it raises some new questions. What are possible limitations to the concept of person-hour? What are some other new units that may not have direct physical meaning, but are formed by taking a product of more familiar quantities? When you have completed your responses, please reply to the response of one other student in the forum. Something slightly different happens when we use multiplication to combine groups of the same size. The apples we looked at in the first session were grouped into 3 apples per pile. We multiplied this by 6 piles, and the result was 18 apples. The units in this situation are apples per pile, piles, and apples. The same thing happens when we describe driving. If you go 60 miles per hour for 3 hours, then the distance traveled is 180 miles. The units involved here are miles per hour, hours, and miles. These kinds of situations highlight how new units can be created by division as well as multiplication. Miles per hour is often represented as miles over hour, and we implicitly use the fact that multiplication undoes division when we work with these units. The situations we have considered in this session suggest a wealth of new models for multiplication. For example, when we multiply a speed in miles per hour and time measured in hours, the result is a distance in miles. This is a model about rates. The electrical usage of a home is measured in kilowatt hours, a product of the power used by electrical appliances, measured in kilowatts, and time in hours. This is a model about the consumption of resources. In making the creation of new units possible, multiplication is different from addition. In order to add two quantities together, they must have the same units. You can't add apples and oranges, but you can add pieces of fruit. And woe to the student who adds kilometers to centimeters. But as we have just seen, when we multiply, we often don't expect the factors to have the same units. The units may be related, but we can also create new units from old ones. In the online discussion forum, write short responses to these 2 questions. What kinds of things can be multiplied? And what do units tell us about multiplication? When you have completed your responses, please reply to the response of one other student in the forum.